Hello and welcome back to our next lesson. Today's lesson is actually really short because you have a big assignment to work on, so I'm just reviewing some concepts with you. And these concepts should be already familiar to you. You've seen them when working with linear functions, as well as earlier in middle school, you might have seen them with different points. So now we're going to be applying these concepts to quadratic functions. So to do that, we're just going to review what each of those are, and then you can get started on your assignment, which is attached to the lesson. So in geometry, we have different transformations, which are pretty much ways that you can move points about on the grid. Our first way is translation, and that's like sliding. So as you slide a point right or left, or if you move it up or down, this is called a translation. And then you will just say the point has been translated however many units and the direction. So for example, I might say X was moved to the right by 3 units. And when working with the Cartesian plane, because we don't have set units, we just say units as a general measurement. So our next transformation is now reflection. So reflection is when you reflect a point across a line, and the reflecting point is going to be on the opposite side of that line and equal distance apart. So typically you might have seen reflection across the x and y axis. So starting with my point A, I might reflect in the x axis to get A prime, and then reflect in the y axis to get A prime prime. And here, if you notice, this distance is the same as this distance from the x-axis, and they are both well, in mine, it looks a little off, but they should be the same distance from the y-axis as well. But this doesn't always have to be about the x and the y-axis. We can also have, for example, a point here, and we could have our reflection line be something like this. And you are still reflecting this point across this line. Maybe let me draw it like that. And now these 2 points are the equal distance apart from that reflection line. So your reflection line can be any linear line, vertical, horizontal, or going diagonally. Next, we are looking at rotation. So for rotation, you are rotating a point about another point, which is our reference point, and you can rotate with respect to degrees. So you can go a full 360 degrees, considering a circle, and you can go in clockwise or counterclockwise direction. So your point is going to stay the same distance, but now it's just going to be rotated. So you might have typically seen, if we have point A there, that it is reflected about the origin, which is our 0, 0 point. So if I reflect this 90 degrees clockwise, I'm going to end up here. And these two are the same distance apart from that origin. I can also go 90 degrees counterclockwise to get to A prime prime there. So with rotation, it's important to have 3 key pieces of information. The point that you're rotating about, so the reference point, how many degrees. So typically, you might have seen 90, 180, 270 degrees in the past, but you can certainly be working with anything within the 0 to 360 range. And you need the direction, so clockwise and counterclockwise. And our last information for geometric transformations is dilation. So that's essentially resizing, and a shape can be resized by a scale factor. So if your scale factor is between 0 and 1, you are multiplying the dimensions of your shape by that scale factor. And if it's between 0 and 1, your shape is actually shrinking and becoming smaller. However, if your factor is greater than 1, when you multiply the dimensions are growing, they become bigger, so your shape is also larger. And I hope you realize that when scale factor is 1, it's just the same shape. So now knowing those, let's look at a couple examples here. So and specifically on the Cartesian plane. So here we have point A, which is 1, 2. And I've shown you in orange, if we translate 2 units to the right, we get to point B. And if we rotate 2 units, oh, this should be 1 unit up. 1 unit up, we get to point C. And we can have more than one translation happening together. So I can move it 2 units to the right and 1 unit up to end up at, for example, let's say here, point D. So you can have multiple translations. Next, for reflection here, we have some examples that I've shown you. So the first example is when A is reflected across the x-axis and the y-axis. So in B, we have that reflection across the y-axis. You see that this is 1 apart. This is also 1 apart. And for C, which is the reflection in the x-axis, we have that distance of 2 and distance of 2. Now, here I gave you the example where we are reflecting across the line x equals 2, which is right about there, and we end up with point D. And you can see that this distance is also the same distance apart. We have 1 and 1. Now for rotation, here we start with point A at 1, 2, and if we rotate 90 degrees counterclockwise, or that's the same as saying rotating 270 degrees clockwise, we actually end up, oh, these two should be switched as well. I will fix all of these for you on your slides, but here we have a minor error. Okay, so yes, we actually get to point C here, and I'll switch the colors for you as well, because this is that 90 degrees counterclockwise and the 270 clockwise. And point B, the key thing here is when you're rotating 180 degrees, it actually doesn't matter if you go clockwise or counterclockwise because you're still going to be going the same distance and you'll end up at the same point. So you can just say rotate 180 degrees and these two will fall in line as well. They will be, because they're being, as you rotate it, they do end up on the same line. Okay, and let's look at our last example, which is dilation. So here we start with shape A. So this one has side lengths 4 by 4. So here I've gone from A to B by multiplying by a scale factor of 2 to get side lengths 8 and 8. And here I've multiplied by half to get a square of 2 by 2. And this is how dilation would be. It's just resizing to bigger or smaller shapes. So now that was our lesson. So now that you're a little bit more familiar with the transformations and you've seen it with points, please try it now with the assignment for today for quadratic functions. Best of luck.